Hey guys, so where we left off was if it's not a perfect square, what do we do? So they gave us 24, and what we're gonna do is make a factor tree. And I like to just start off small. We're utilizing factors of 24. So let's just start off by dividing 24 in half, okay? Which would be 2 times 12. So 2 can't go any further. It can't be simplified anymore because it is a prime number. Remember, prime numbers can only be divided by themselves and 1. However, 12 can be simplified. So if we divide it in half, we get 2 and 6. So another prime number, but 6 can go further. When we have 2 and we have 3. So 2, again, another prime number. 3, again, another prime number. So now we're done, okay, with this part. So now what we're going to do, since we are taking the square root, we're going to look for pairs, okay, pairs of the same number. And we're going to circle those pairs preferably together because it's going to help us in the long run. So we have a pair of 2s right here. Do we have any other pairs? No, we do not. So here's the thing I forgot to say. The numbers that we are looking at are the numbers literally on the end, dangling off the end by themselves. They're all alone. They don't have any friends. Okay, those are the numbers that we're looking for when we're going to look for our pairs. All right. So the only pairs that we have are these 2s right there. This 2 and this 3 is left by itself. So what we're going to do is we have one pair of 2s. We're only going to use the actual number, which is a 2. And then underneath our radical, we're going to use the numbers that we underlined, which was 2. And then we're going to multiply the 2 and 3. 2 times 3. Simplify it. It's going to be 2 times 3 is 6. And then we're going to just bring down our 2. And then this is going to be our answer. Okay, let's try another one. Let's try one that's a little bit more simple. However, with this one, I think we can do it a different way instead of breaking it down so far. Well, one, it's an odd number, so you can't divide it by 2 and get a whole number anyway. So let's think about our multiplication facts. What times what gives us 45? We know that this is an easy one because it's 5 times something. So 5 times 9 gives us 45. So 9 and 5 are factors of 45. So we can use that. So again, when we are using factors, like whatever factor you want to start out with, it doesn't matter. It doesn't matter. All that matters is that we keep breaking it down until we get to the prime numbers. Okay? So with 5, we can't go any further. That's as far as we can go. So let's break down 9. And 9 is 3 and 3. 3, another prime number. So now we're going to look at pairs. The only pair that we have is this 3. So we're left off with the 5 because those are the only numbers dangling. The 5 is dangling by itself. It doesn't have any company underneath. The 9, it has company underneath. See, it has those 2 3s. However, these 3s, they don't have any company underneath. This 3 doesn't have any company underneath. So that's why we know that these are dangling by themselves. And those are the only numbers that we are concerned about at this time. So again, we found our pair. It's a 3. We don't use both numbers. We don't do anything with both numbers. We just used the number, which is 3. So 3 is going to go on the outside of the radical, and then 5 is going to go on the inside of the radical. And then that's going to be your answer. So again, you took the number 3, it went on the outside, there was only a 5, and the 5 went under the radical, and that's your answer. You just simplified the radical 45. Let's try to do 72. So the square root of 72. Let's go ahead and let's do the 2's on this one. So 2 times 36 is going to give us 72. All right, let's break down this 36. I'm going to do 2 again. However, if you wanted to, just think about it. What other number could you put here? What other numbers could you put here that equal 36? What other factors of 36 could you put here? Just for the sake of it, I'm going to do 2. So 2 times 18. And then we're going to need to break down the 18 further because the 2 are prime numbers. So we're going to do 2 times 9. So we're going to leave that 2 alone. 9 can be broken down into 3 times 3. Those are prime numbers, so now we're done. So again, we're looking at the numbers on the end of the branches that are dangling off by themselves and have no company. So that's going to be this one, this one, this one, this one, and this one. Why? Because 36 has company. It has a 2 and it has 18. 18 has company. It has a 2 and a 9. 9 has company because it has a 3 and a 3. Okay? So these are only the ones that are dangling and lonely by themselves. So now we're going to find the pairs. Let's find the pairs. So, there's one pair of 2. Cool. Any other pairs? There's the pair of 3. Are we done? We're left over a 2. Okay. So again, we have a pair, and we're just using the number again. And that's what you're circling, the pairs, that goes on the outside of the radical. So we have a 2. What else do we have? We have a 3 times 3. Don't forget, we always multiply them. And then underneath the radical is going to be the number we underlined. So under the radical, we only have one number, so we're going to put the 2. So 2 times 3 is 6. And then we're just going to bring down the radical 2. And then that'll be your answer. 6 radical 2. Probably should have used multiple colors. Let's try one more. Let's do 96. And what I'm going to do is I'm going to do 96 2 ways. I'm going to do 96 2 ways just to show you that you can use like any factor pair. Okay. So let's start off doing 2s. Let's start off just dividing by 2. Okay. So let's make our branches. So 2 and 48. Because 2 times 48 is going to give us 96. All right, so now we're going to do the 2's again. Remember, we're going to keep going by 2 since it's an even number. So 2 times 24 is a factor pair of 48. So again, we're not doing anything with this 2 because it's a prime number, but this can be broken down. Let's divide it by 2. 2 times 12. Okay, 12 can be broken down into 2 times 6. And then 6 can be broken down into 2 times 3. 3 is a prime number as well. So now we're done. And again, we're only looking at the ones that are dangling off by themselves and don't have anything underneath them. So now what are we going to do? You tell me, what are we going to do? You guessed it. We are going to find our pairs. So we have a pair right here. Oh, we have another pair right here. So just to be clear, the pairs don't have to be like a 2. It can be a pair of 3s, a pair of 4s, a pair of 5s. It doesn't matter. All right, so we have 2 pair of 2s, which means we're going to take the number from each pair, right? So that goes on the outside. So we'll do 2, because there's 1 pair of 2s, another pair of 2, times 2, and then the numbers that we have left over by themselves is 2 and 3. And those are the numbers that'll go underneath the radical, remembering that we're always multiplying them. So to be 2 times 3. And then all we'll do is just multiply them together. So 2 times 2 is going to give us 4. 2 times 3 is going to give us 6. So that's your answer, 4 radical 6. Okay, so we did that by dividing by 2. I just want to do the same thing because I said that it doesn't matter what factor pair you use. Okay, so I just randomly divided. I was like, hey, well, let me just try and see if 96 is divisible by 6. And it was. So it was 6 and 16. That's where I started, okay? So now we need to look at those 2 numbers and see, well, can they be broken down more? Let's start with the 6. Can 6 be broken down some more? It can. It can be broken down into 2 and 3. And we know those are prime numbers, so we're done with this side, okay? Now let's look at 16. Let's break it down. So we can do 2 times 8, and then our 2 is done. Let's break down the 8. We know 2 and 4. And then let's break down the 4, which would be 2 and 2. All right, so now what we're going to do is find our pairs. So here's a pair of 2s. Here's a pair of 2s. And we are left with a 2 and a 3. Same thing. Our pairs, there's 1, 2, 1 pair of 2s. That's a 2. Another pair of 2 times 2. And then underneath our radical is what we underline. So there's a 2 times 3. And we multiply, we get 4. And then underneath our radical, 2 times 3 is 6. And again, there's our answer, 4 radical 6. So you can see that it doesn't matter which factor pair you start with. You're going to come up with the same answer. It just matters how big you want your tree. So if you guys have any questions, please feel free to email me or email Mrs. Walton with any questions that you may have. Oh yeah, one more thing, just because when it's a regular perfect square, you just leave it as is. So the perfect the square root of 36 is just going to equal 6. And then that's going to be your answer, because 6 times 6 is 36. Okay? All right. If you have any questions, please feel free to email me. Have a good day, guys.